Okay, so building off of just the info from the page before this or from class, that there's this idea that we have vertex form and it tells us where the vertex is, and then we can use that to draw a parabola. I'm going to do these top 3 as examples, and then there are 6 graphs for you to do on your own. Definitely make sure you're checking your answers, and as you check your answers, it's not enough that it's a parabola. It also has to be, like, your points need to be where my points are. Basically, I want 5 points, the vertex, and then 2 on each side. And so you need to, make that happen correctly or something. I don't know. Okay, let's do this first one. So this is in vertex form, and what we're going to do is pick out the vertex. I'm going to put parentheses because it's a point. I'm going to also say, V. It does also ask me to describe the transformations, which is going to be easy to do because we have to figure out the transformation. I want us to figure out the transformations to graph it. So what I do is I take this number inside that is affecting x, and I say, well, that's the x value of my vertex, but it's part of the super secret opposite society. So it's not a -3, it's actually a +3. And then I take this number on the outside and I say, oh, you're not a part of the super secret opposite society, so you are in fact 1 for the y value. So I would go right 3 and up 1 and make a dot for the vertex. And then I talked a little bit on the form about how what's in front of the parentheses tells us which direction it's opening and tells us how fast or how slow it is. In this case, we don't have anything, which means we have 1. And so this is going to be a normal parabola. So from the vertex, to draw this parabola, I need to go out 1, left and right, and up 1 to make my first 2 points. Out 1 and up 1. Then, again from the vertex, I want to go out 2 and up 4, because 2 squared is 4. But because we're doing it over here where the vertex is, that's taking into account the -3 and the +1 without us having to actually do all that math ourselves. Not that it's hard to do that necessarily, it's just time consuming. And then I can draw my parabola. So what were our transformations? We can get them from the vertex that we had to shift right 3 and up 1. So that's what I want you to do. Most of these are really similar, so it's really about like gaining the confidence to be like, oh yeah, I know how to do this. I'm doing it right for the first try, and it's going really well. And so, what's next? How do we make it harder? And that's what we'll do on tomorrow's day. Okay. Let's see. This one says x + 4 squared + 2. So our vertex is the opposite of the inside as our x value, and not the opposite, the normal of the outside, which is our y value. So my vertex is at -4, 2, and I don't have anything today. In fact, you may have a negative in front, which would mean that you would need to make it open down instead of up, and we'll see that happen on this, which is, so I think all of these pages are not going to have C and just have B again. That's awkward. So we could have a positive or negative that tells us to go up or down, but that's pretty much the extent of today's difficulty. So since this doesn't have anything in front of it, which means it's like a +1, I just go out 1 and up 1. So ignore that little point. And then out 2 and up 4. And it just occurred to me actually that, like, that's how I like to remember it because of squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. And so you go out and up with using those numbers. But you might enjoy, if you're a pattern person, the fact that this gap is 1 and this gap is 3. The next gap would be 5, and then 7, and so on. So the gap between these points going up and down, the pattern is actually, you can actually say it's going up by consecutive odd numbers, which I think is really cool, personally. So C, or second B. Now, this doesn't look like vertex form because we don't have parentheses. And that means that plus 8 is not inside parentheses. It's still the 8 that we need for our y value of our vertex. But what do we do about the fact that there's not parentheses? What does that mean our x value is? Well, if there's not parentheses, that x value has to be 0. So I could have written this as x minus or plus, got carried away, 0, that's what I meant to say. I could have written it like this. Why didn't I? Because that minus 0 is extra information that we don't actually need. So if you don't see parentheses, that makes your x value 0. If you don't see a number out to the side, like we've had on each of these, that would make the y value 0. Oh, I didn't put the transformations on this one. So left 4, and you're basically just describing where we moved our vertex. Up 2. So then we start at 0, 8, and it's a good thing this is opening down because we don't have a lot of room to go up. I am sure that some of these are going to go off the graph because I didn't try unbelievably hard to make sure that they wouldn't. So just make do with what you can. If it really bothers you, do a piece of graph paper to draw it the way you want it. But just know that there is a chance that it can go off the graph. So make sure you check your answers. So normally we go out 1 and up 1, but the negative is going to make us, from the vertex, go out 1 and down 1, so that it opens down. And then it's going to go out 2 and down 4. And this is what our parabola looks like. So our transformations, we don't have a shift left or right because it's 0, but we do have a shift up 8. And we also want to describe the fact that it's an upside down parabola. So we call that a reflection over the x-axis. And that's to specify that the way we are reflecting it is over this way, as opposed to over this way. More on that later, probably, but that's the idea. So check it out. Make sure you check your answers. Thanks, bye.